Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Today I will continue the properties of metal and non-metal. And in our last class, I have discussed about the properties, some properties of metals and non-metals. And today I will continue. I will discuss about some more um, physical properties, mainly physical properties of metals and non-metals. And metals and non-metals are two classes of elements, and we know 118 elements. Okay, 118 elements are invented in the universe till now, and most of them are metals. Okay, most of them are metals, and at first, today I will start with the very important and properties of metals, which is electrical ele- electrical conductivity of metals. Okay, and metals are a very good conductor of heat. We have learned about that. And also metals are very good conductor of electricity. And that's why they are called conductors. Okay, and so we have to know what is conductors and what is insulators. Okay, and the conductors are the materials that can flow electricity, that can flow electric current through them easily, and the insulators cannot flow the current through them. Okay, in a conductor, electric current can flow freely, very freely, and in an insulator it cannot. Metals such as copper, aluminium are very good conductor. Okay, almost all metals are conductor, but metals, copper, aluminium, gold, silver, these metals are very good conductors, while most non-metals are said to be good insulators. Okay, and they are bad conductors. Insulators, they cannot conduct electricity, and having the most non-metallic solids not good are not good conductor, because having extremely high resistance to the flow of charge, negatively charged electron. Okay, okay, through them, they resist the flow of electron through them. And we know electricity is the flow of electron in a wire or in a metal piece. Okay, that means electricity is flow of electron. And electrons are, we know about that, electrons are atomic particle, and these electrons are negatively charged tiny atomic particles, those present inside the atoms. Okay, inside the atoms. And uh, the atoms in the metals have a very special structure. Look at these pictures. Okay, yeah, this is a picture of metal rod and metal piece, and this is the structure of glass rod. Okay, and this is also, this shows the metallic structure. Okay, metallic structure of a metal piece, metal piece. And from this structure you can, we can say that the atoms in these metals form a special, very special type of structure. Okay, and through which some of its electrons can move freely. In this picture, these blue color tiny particles are show you the electrons. Okay, and these white colors in both the pictures, these white color circular balls show you the atom or molecule. Okay, these are atoms or molecules. We know all the matters are made up of are tiny particles which is known as atoms or molecules. And um, and if you look at this picture, this animated picture, you can easily see the movement of electrons. Okay, these yellow balls are metals and metal atoms, and they are well organized, closely packed, and they cannot change their position, but they some of its electrons can move freely inside the whole metal piece. Okay, and these electrons are no longer firmly held by a specific atom. They are freely moved, and they are not firmly held by these atoms. Okay, and they are free from the atoms, and that's why we know flow of electron is known as electricity or current. That's why these the movable electrons are responsible for to make metals conductor. Okay, and most of non-metals atoms hold on to their electrons tightly and are insulators. Okay, this is a non-metal compound, glass rod, glass, and here no free electrons are present in their structure, only the atoms or molecules. So they are insulators. They are bad conductors. They cannot create the flow of electron, and that's why they cannot conduct electricity also. Okay, and now this metal rod is conductor, and we can say this glass rod is insulator. And now, uh, how exactly is the electron flowing in the circuit? We we now I will show you a special arrangement which is known as circuit. Okay, and through which material is the current flowing, we have to know. And this is the arrangement of a circuit. If we connect the battery, you can see there a battery. If we connect a battery with a bulb through two copper wires, okay, this is a battery, this is the bulb, these two are connected by two copper wires. These two wires are copper wires, insulated copper wires, insulated by a insulator. Okay, this is covered with plastic. Okay, and the if we connect this battery with a bulb through this metal copper wire, then the electrons will flow from the negative terminal to the positive terminal. Okay, this negative terminal to this is the we can see easily you can see this term, this end is positive end of the battery, and this end is the negative end of the battery. In negative means this part is electron rich part. Okay, they can and release electron. When we this wire is connected with this terminal, then electrons will flow from this negative terminal to the valve, and then through to the negative positive terminal of the battery. Okay, and then here a flow of electron is created, and that means there will be flow of current electricity from um, positive to negative end. Okay, and mm, you can see that these arrow signs are showing you the flow of electricity. This is exactly opposite in direction of flow of electron. Okay, and it will be more clear than from this picture. Okay, this animated picture you can show this is electron rich terminal, this is electron, this is positive terminal. Okay, because this is represented by minus sign, because we have learned about that electrons are negatively charged particle of atom. Okay, and this electron is released, and these electrons flow through this metal wire. Okay, through this metal wire. This wire is made up of metal, and from this easily move electron, and this movable electron create the flow of current in exactly opposite direction. Okay, this is the direction of positive to negative to positive is the direction of electron, and the negative to positive is the direction of electron, and the positive to negative is the direction of our current flow. Okay, and now uh, if we cut, okay, if we break the circuit, okay, if we break this circuit anywhere from anywhere by cutting the wire, okay, this can be also done by this way, using this wire also, but in that portion, and shown the circuit from anywhere is cutting the copper wire. Okay, now look at the broken part. This part is broken part, and there is nothing present in this part that can transfer the electrical energy, that can transfer the flow of electron from one side to other. Okay, there is no connection, so the flow of electron is disconnected. Okay, and that's why but one thing is present, the air is present. Okay, there is air, and from this we can say air is an insulator. Okay, because the light doesn't, this bulb doesn't light. Okay, this bulb doesn't glow. Okay, and so if we connect the two wires, now we can and show that we have to discuss that. And if we connect the two wires by a glass piece or a plastic, then what will happen? Okay, we these two cutted wires as will be connected by using another materials. Okay, and then what will happen? And now I will discuss an experiment, and that will allow you to identify those materials that are electrical conductors. Okay, and that are not conductors. Okay, and for this activity we need iron. Our requirements is iron rod. Okay, this is the iron rod, and we know iron is a metal, and this is a coal or charcoal piece. We can say the carbon piece. Okay, a non-metal compound piece, and non-metal piece, and this is copper ware. Another important metals which are widely we know about that is which is a good conductor of heat, and also it is a good electricity conductor, and a piece of plastic. Okay, and insulated electric wires, and a bulb. Okay, and now make an electric circuit. We know we have just now known about electric circuit. Okay, and now we have to make an electric circuit with the help of two electric wires. You can see black wire and another wire is red wire. Okay, these two wire, and a battery. This is the battery. This black, this is the battery, black and red mixture, this structure. Okay, and this is the bulb. These three things are used to make an electric circuit. Okay, and now connect the iron rod. Our iron rod, connect the iron rod between the open ends of the ears. We have to open two wires. Okay, one end of the wires, two wires. We have to open one of the ends of these two wires. And what we see now, uh, look at this picture. This From this picture, you can see easily that the bulb glows. Okay, the bulb lights, and it means that iron rod is a good conductor of electricity. Okay, this is the position of iron rod. Okay, and it means that iron is a good conductor of electricity. Now connect the coal piece. Okay, the our carbon piece. From this picture, you can see uh, this two free end is connected with the coal piece, and um, the open ends of two wires are connected to this coal piece. But you will observe that now, you can observe that the bulb does not glow this time. It shows that coal is a bad conductor of electricity. On repeating the same activity with copper wires, and copper wires, we can see that the bulb glows. On the other hand, when the piece of plastic is connected, this is the piece of plastic, and between these two ends, between these two open ends of the wires, the bulb does not glow. That means uh, on this basis of these observations, these four observations, these materials can be grouped as good conductors and bad conductors of electricity easily. Okay, and you can see from the table, this table, and we can see it metals, mainly metals, iron and copper. Per iron rod and copper wires are good conductors of electricity, and coal and plastic are bad conductors of electricity. And from this experiment, and you have learned that, you have very easily learned that metals are good conductor of electricity, and that means that they allow electric current to pass through them. Okay, and now you might have noticed that many times electricians use an electric tester. Okay, like this. Okay, a tester that has a plastic insulator. Look at this portion. Okay, this is the plastic insulation at the touching or holding end. Okay, our holding end is insulated by a plastic materials. And why is it so? Okay, and this is because a tester is insulated by this plastic to protect the holder. Okay, to protect the holder from electric shock. Okay, we know about electric shock. Okay, and to protect the holder from electric shock, because it is a bad conductor of electricity. That means the holding place is insulated by, is covered by a insulator or bad conductor of electricity. Okay, and we can summarize. Look at this animated picture. You can easily observe this fact again, and this is the wood piece, and our light doesn't glow. And this is copper, our light glow. This is glass, our light doesn't glow. This is steel. Steel is a mixed metal alloy. Okay, steel is a mixed metal alloy, and they can also conduct electricity. Okay, and this negative end with this, and this positive end with this light. Okay, and from this discussion we can say some solids are good conductors of electricity, such as copper, steel, iron, aluminium, etc. metals. Okay, and some solids are conductor poor conductors of electricity: wood, plastic, rubber, glass, etc. And now there is a list and the most conductive elements of the periodic table. That means periodic table is a table in which 118 elements are organized in a very well manner, in a very systematic manner. Okay, and from this table, here the most conductive elements are listed, and in this list silver is the most conductive elements. Okay, and then copper, gold, aluminium, and this informations, this list is just for your knowledge. Okay, and this if we can remember this is your GK knowledge will improve. Okay, will be improved. And now let's go on to non-metals. Okay, non-metals, another branch of our elements. Okay, and non-metal is just the opposite of metals. And non-metals we can simply define as the non-metals are the elements that doesn't show any metallic properties. Okay, that doesn't show any metallic properties, and these are called non-metals. Okay, that means we can define non-metals. A non-metal is an element that is neither malleable nor ductile and doesn't conduct electricity and heat. These all are the properties: malleable, ductile, conduction of heat and electricity, all the properties of metals. And non-metals doesn't show these properties. Okay, and they also, they most of them are not shiny also. Okay, look at these pictures. This is the carbon, and this is sulfur. These are non-metals. These all are non-metals, and non-metals can be solid, liquid, or gases at room temperature. Okay, and these two are sulfur, carbon, sulfur, phosphorus, etc. are solid non-metals. And now this is oxygen. We inhale oxygen. Without oxygen we cannot live. And this oxygen is a gas. We know about that: oxygen, nitrogen, chlorine, fluorine, and then these are non-metals, and these are gas. Maximum non-metals are gaseous in state. Okay, at room temperature. And this is bromine. This is bromine. This is liquid. Okay, this is bromine. This is liquid non-metal at room temperature, and oxygen is gas. That means non-metals can be solid, liquid, and gases at room temperature. And now we can make a comparison between metals and non-metals. Okay, properties of metals versus non-metals. Okay, look at this table, and from our previous discussions and today's discussion, we can and make this table. Number one, and lustrous. That means metals are lustrous. That means they are shiny. Okay, and non-metals are dull and non-lustrous. And lustrous means they are not shiny. Okay, and from our previous pictures we can easily we have easily observed that the sulfur, the carbon, all are dull, not shiny. Okay, and number two, usually solids at room temperature except mercury. Okay, mercury is a liquid metal, exception. Only one metals are liquid in phase, otherwise other usually solids are at room temperature solids. Okay, metals are solids, and non-metals can be solid, liquid, and gas at room temperature. And number three, metals have and metals have high boiling point. Okay, and metals usually have very high melting and boiling point. So for a metal to melt, to change from solid to liquid, it needs a lot of high temperature. Or imagine the boiling of metals, that means gaseous metal, it needs a further temperature, that means a very very high temperature. And that's why metals have high melting and boiling points, but non-metals have comparatively low melting and boiling points. Okay, and next, the density. Similarly, metals usually they have high densities because they are solid. Maximum metals are solid at room temperature, and we know that solids are closely packed. They are more dense compared to liquid and gases. And we know density. What is density? Mass by volume. The amount of mass per unit volume is known as density, and so metals are usually having higher densities. Metals are usually having higher densities, and densely the tiny particles are densely packed. They have higher mass per volume ratio, and non-metals have low density. Okay, and another very important property is our number 5, sonorous. Okay, another property, important property, which metals have a sonorous sound. Okay, sonorous sound. And sonorous is the what is means sonorous? Sonorous is the property of metals by which they produce ringing sound. Okay, they produce by which they this is the property by which they can produce ringing sound. And this is the thing which made metals to produce ringing sound when they struck hard. Okay, when they struck hard. And but non-metals are non-sonorous. It doesn't make any ringing sound, any jingling sound. Okay, when they strike, when they struck. Okay, and now the this from this picture you can see the sonorous sound. This is made of metal, and we know about the ring bell. They can make ringing sound. And now metals are malleable. Number 6, metals are malleable, but non-metals are non-malleable, not malleable. That means they are brittle in nature. Okay, they are basically brittle. They cannot be beaten into thin sheets. Metals are ductile also, and we know metals are ductile. The special property of metals, they can be drawn into thin wires like copper wires, aluminium wires. Okay, and but non-metals are non-ductile, which means you cannot stretch them. You cannot stretch them into wires. And metals are usually good conductor of heat and electricity, and non-metals are not good conductors of heat and electricity. And this is that's the hopefully from today's lecture, you can easily differentiate between the properties of metals and non-metals, which is very important for uh, very important topics of this chapter. That's all for today, students. Assalamu alaikum.